Okay, today we're gonna continue talking about the sequence types. If you remember, we started talking about sequence types last lecture, right? So we talked about the string, lists, tuples. We didn't talk about ranges yet. Okay, we're gonna start talk about ranges today. But before that, do you remember when we talked about the mutable versus immutable objects? So what is the difference between a mutable object and immutable object? Yes. Yeah. Yes, mutable, the object itself can be modified after creation. If it's an immutable, so the object itself cannot change, even though when we try to make a change operation, the operation seems as if the object changed, but what happened behind the scene is that a new object was created, and now the pointer or the variable that represented that object points to the new one. Okay, now that's something that we need to be careful about when we have a list of lists. Okay. Okay, so when we have something like this, a list like this, that has some elements that are mutable and some elements that are immutable. Okay, so we have this list here that has a string, and the string is mutable or not? String is mutable or not? No, it's not. String is immutable. This is another list, right? It's an empty list, right? The list is mutable or not? The list is mutable. So the list surrounded by square brackets is mutable. A tuple is mutable or not? No, it's not mutable. A tuple is immutable. Okay? So what happens when we create a copy out of this combination? Okay? So let's say here we wanted a repeated list, so we wanted to repeat the my list twice. So what happened is this repetition or the concatenation, like it's just repeated concatenation, right? So it creates a copy of the original list and concatenate it to itself, right? So the result of this multiplication or this repetition is a new list that has the copies of the elements, right? Right? Now, what happens if we change one of these elements? Now, depending whether it's mutable or not, that change may or may not be reflected in all of the copies. Okay? So if we just this is what I'm gonna describe right now is shallow copy. So let me just put up this screen here. Okay, so let's see, we have this list. So when we have this my list, we have a variable called my list, right? Remember this assignment has three steps. There is a variable called my list, and then there's the list object itself, right? So somewhere in the memory there is an object, a list object here. So let's say an address 1, 2, 3. Okay. And then the assignment will put the address in the variable, so the variable would be pointing at that object, right? Now that object happened to be a list, so it has 3 elements in it accessible by index, right? So the list itself is actually 3 different variables. Each of them is accessible through the name and the index, right? Now the first element here is a string. So string itself is an object, right? So there is the object of the string itself. Let's say that's an address 456. So the address of that object is stored here, and that's where it's pointing. Okay, and then we have another, let's say 222. That is the empty list. All right. So this is here, 2, 2, 2, pointing here. And then the last one, this is the empty tuple. So let's say this is an address 333. Okay. Now, when we create a copy of that list, what is it that we copy? What is it that we're copying? Are we copying the object? No, we are copying the addresses. All right. So when you create a copy of this list, you're creating another object that is a copy of whatever is stored there, which is the addresses of the objects. Okay. That's pointing here, that's pointing here, and that's pointing here. Okay, so this is the copy. Now let's say I use the copy. So let's say a copy itself. So I'm gonna teach it. Okay. So let me say just a copy. Okay, I copied that list and put it here. So the copy itself is in another application. So let's say 555. Okay. Now I wanted to change the string. Okay. So when I change the string using this address, so if I say the copy of 0, I'm pointing at this address, right? So I want this to be plus equal x, y, z. So plus equal means I read the original copy, which is A, B, C, and I append x, y, z to it. This is the new value. All right. Where do I put this new value? The same object here? In a new object, right? So we have a new object. So let's say this is 999. And now the variable that was pointing to the old object is now pointing to the new object. Right? Now, what if I wanted to change the list from here, from the copy? Now, if I said copy of 1 plus equal 1, 2, 3. So what happens that plus equal, I read the old value, which is empty, append to it 1, 2, 3. Now I have a new list that is 1, 2, 3. Where do I put this list? In a new object? No, because list is a mutable object, right? So where do we put this? Where do we store this? In the same old object here. Right? So now this list, I'm just going to put the list, it's another object. So now the copy and the original values are the same, right? Because this object is mutable. But when the object is immutable, the copy and the original value may deviate, right? Now, what if I try to change the tuple from the copy? Where is it going to be seen? It will only be seen in the copy, right? The original value will remain the same, right? So if you have something like this, and you have a copy, so you here when we created the repeated list, we copied the values that were in the original list and appended them, right? So these two will right now will be pointing to the same object. So if we print them, it will print the same object. But I happen to change one of them. So I happen to change the string in the first location here. Now, if I printed the entire list, the copy remained the same because it's an immutable object, so the original object didn't change. But this value changed because this is the one where I assigned the new object to, right? Now, if I try to append something to the list, this one, and then so I only use the first index here to make that change. Now, when I printed both the original value and the copy can see the change because both of them are still pointing to the same object, right? Now, if I try to change the tuple, so depending on the location I use to reference to assign the change, only that location will reflect the change. Okay, so if I use location 2, which is the first occurrence here, so only that one will see the change. The other, the copy, will not see the change. Okay, is this clear? No? Yes or no? Yes? Okay, so you have to be careful with that. There are subtle details that might be confusing when things get complicated. Okay, so that's what we call the shallow copying. When we copy, we just copy the address of the object, not the object itself. Any questions about that?